In this video, we're going to practice some problems where we apply the empirical rule for normal distributions. Let's read the question here. It says, in a mid-sized company, the distribution of the number of phone calls answered each day by each of the 12 receptionists is bell-shaped and has a mean of 35 and a standard deviation of 4. Using the empirical rule, what is the approximate percentage of daily phone calls numbering between 31 and 39? There's a number of ways you can approach this. If you have um, seen the previous video where you followed along and set up a spreadsheet to help you with z-score calculations, then it's very easy for you to go ahead and just put in the mean of 35 and the standard deviation of 4. And now all of my values have calculated in an instant, and I can see all the x values that are the receptionist times that line up with a z-score of 0, a z-score of 1, 2, 3, and so on, -2, -1, -3. Okay, so how do we understand this in terms of this question? It says, what is the approximate percentage of daily phone calls numbering between 31 and 39? Well, here's 31 and here's 39. How many standard deviations away from the mean are each one of those? Well, they line up with a z-score of 1 and a z-score of -1, so they're within 1 standard deviation of the mean. And the empirical rule said we have 68% falling within 1 standard deviation of the mean if it's bell-shaped distribution. So that's going to be my answer, 68%. And I have that also down here. Remember, I planned this out so that it's always referring to the two cells for 68%, this value and this value. They're always referring to those scores that line up under a z-score of -1 and a z-score of +1. So my answer here is 68%. That was pretty easy. Let's do one more of these, new version. Now notice they've given me the same setup, the mean of 59 and a standard deviation of 5. So I'm just going to change this to 59, standard deviation of 5, and then come down here and see these two values they gave me, 49 and 69. That's 2 standard deviations away from the mean, so that should be 95% is within that range, right? Those are the values that line up with a z-score of -2 and a z-score of +2. So 95%. All right, let's try another empirical rule problem. In a mid-sized company, the distribution of the number of phone calls, okay, it's the same setup, but now we have a mean of 39, a standard deviation of 4 again. So we'll go ahead and change that back. 39 and 4. And using the empirical rule, what is the approximate percentage of daily phone calls numbering between 27 and 51? Okay, so 27 and 51 here is 27. 51 is here. I also have that showing up right in here, which corresponds to, I need to make this bigger, 99.7% according to the empirical rule. Now, you might be wondering, well, if I didn't set up this whole thing, how would I get my answers? Well, you can convert each value they give you to a z-score, and that'll tell you how far away it is from the mean. So let's say I just take 27 and convert it to a z-score. So I would do, the z-score formula is up here. You see, you take the x value minus the mean quantity divided by the standard deviation. So if I put 27 in here, I've already got it set up to calculate for me. If I put 51 in here, it's going to give me +3. right? Because it's within 3 standard deviations of the mean, 95%. Okay, but if I needed to do this without having a calculator already pre-built, I would just do parentheses 51 minus the mean of 39 quantity divided by the standard deviation of 4. And then I would know, oh, it's a z-score of 3, so it has to be the 99.7%. Okay, let's try that again here. We have a mean of 48, standard deviation of 6, and I want to know what percentage is between 36 and 60. So if I was doing this by hand, I'll take 36 and convert it to a z-score so that it'll be equal to the x value minus the mean quantity divided by the standard deviation. And you're also welcome to just type those things in. So I'm getting -2, so this is going to be probably 95%. If you want to just check the other value to make sure, 60 will give me a +2. So yeah, 95% within 2 standard deviations of the mean. Here's another one. A physical plant at the main campus of a large state university receives daily requests to replace fluorescent light bulbs. The distribution of the number of daily requests is bell-shaped and has a mean of 38. Ooh, let me write that down. 38 and a standard deviation of 11. Okay, mean of 38, standard deviation of 11, using the empirical rule, the 68, 95, 99.7 rule. What is the approximate percentage of light bulb replacement requests numbering between 27 and 38? Okay, so I'm going to come down here and see that 27 is 1 standard deviation below the mean, but 38 is not. So it might help to look at the way they lay out here, or you can just convert them each to z-scores. But what I'm finding is that 27 is 1 standard deviation below the mean, and 38 is actually the mean, right? So normally, if you were within 1 standard deviation of the mean from below and above, we would expect 68% of the values to fall in that range. But now we're only talking about half the distance. So we're going to take the 68 and divide it in half to get 34. What about between 57 and 84 with a mean of 57 and a standard deviation of 9? Okay, so 57 and a standard deviation of 9. So the z-score for 57 is obviously going to be 0 because that's the same as the mean, right? And the z-score for 84, and I'm getting these numbers from here, for 84, that would be 3. So normally, if you're going all the way from -3 to +3, you would have 99.7% between 30 and 84. 30 and 84. 3 standard deviations below the mean and 3 standard deviations above the mean. However, I'm not going all the way from -3 to +3. I'm going only from -3 up to 0. So it's going to be half as much. So what's half of 99.7? 99.7 divided by 2, 49.85. Okay. The physical plant at the main campus of a large state university receives daily requests to replace fluorescent light bulbs. The distribution of the number of requests is bell-shaped and has a mean of 36 and a standard deviation of 8. Okay. what percentage lies between 36 and 60? So I can see 36 is the mean, 60 is 3 standard deviations above the mean, so I'm going to have the same answer as before, half of 99.7. Oh, that took a really long time to type. All right, the number of potholes in any given 1 mile stretch of freeway pavement in Pennsylvania has a bell-shaped distribution. The distribution has a mean of 60 and a standard deviation of 10. Using the empirical rule, what is the approximate percentage of 1 mile long roadways with potholes numbering between 50 and 80? Right, so spot the mean, 60, and the standard deviation, 10. 60, 10. So between 50 and 80, that's right here, from 50, 1 standard deviation below the mean, to 80, which is 2 standard deviations above the mean. Okay, so we know that half of 68 is going to be from 50 to 60. So that's going to be um, between 50 and 60, we have 34%. And between from 60 all the way to 80, that's 2 standard deviations. That's half of 95%. So that would be 47 and a half. I think that's right, 47 and a half. So what is 95 divided by 2? Yeah, okay. So we're going to add to that the 34 plus 47.5, and we get our answer of 81.5. Okay, so that's all the examples for this video, and we'll do, what are we doing next? We have, oh, this one, we'll do this in a separate video, where we find the mean and the standard deviation and then use it to find a z-score.